Ladies and gentlemen, my name is Mikhail Matveev. I'm Director for Automatization Center at MTS. I'm going to tell you how we can use data and big data in a factory, using a case of a Micron uralchem factory that we worked with this year. An important moment in factory digitalization is that companies have different maturity levels at this moment. Big data can only be useful when we push the digitalization to levels 4 and 5, when we don't just understand what's going on in a factory, but we're also ready to answer a question, what will happen? And when we use the AI, we can reach a self-perfection level and further development levels. One of the most significant moments for industries right now is that they encounter problems with generational change. And now we have this idea, power of specialists, power of technologists that control the unique knowledge and control the production process. What does data give us? Once we received an opportunity to collect big data, and almost all the processes in an industry were automated, we received an opportunity to gather data and further use it to control the production processes based on the knowledge received, machine learning, and deep learning. Today, another important thing about why factories must think about such improvements is that this way or another, automation has achieved its ceiling in some fields. We see a growth in competition with Western manufacturers. There are some things that are unpredictable, like the pandemic that has affected most Russian industries. And since most of them use Western machinery, they cannot control the repairs, this launch, or a relaunch of new processes. Another important thing is that generations change, like I said. A new Z generation starts to work. They are used to mobile apps, and they use Wikipedia and other sources to get new information. Now, what tasks does AI solve? There are multiple options, multiple ways to use AI. One of them is prevention failures and detecting faulty mechanisms. I'll tell you about it more a bit later. Also, you can control the process and increase product quality thanks to the data you receive. You can find optimal, interesting schedules for the machinery, optimize it, and of course you can reduce idle time. Another important moment that we have demonstrated in our Micron case is preventing defects in products released. In our case, we saw that despite high automation in the production, Micron produces RFID and microchips for Russian market. Now, we saw defects in products released. Finding the reason for this defect was difficult, because there are so many processes and components involved into producing the devices that SMD produces. Now, what could be done? Before, they had to stop everything that worked, check everything, and then relaunch it, which was a lot of time. Ivan Isaev, our data scientist, and the team he leads collected data from all the devices, analyzed it, and found out that when only one of the components is being worked on, there was a defect. It was connected to acidity levels. So we learned of the reason. We learned that we had to change the acid, and we could predict it thanks to machine learning. Now, what have we achieved this way? We've increased efficiency, thanks to reducing idle time by 20%. We also reduced the chemical spent by 8%. And we've achieved correct prediction in 92% of cases, prediction of defects. Another example I'd like to tell you about is using AI on a live production process in chemicals. This case is about producing nitrogen fertilizers. So in this process, we produce pulp. And to measure the quality, we need to know how much nitrogen is in there and phosphorus. It was impossible to do directly, but we could get data from other devices, temperature sensors, humidity, etc. After the research, we found that 7 sensors were enough to get data from, to enable comparison and getting the results from the analytical lab that measured the actual share of nitrogen and phosphorus. So instead of getting data from a lab 3 hours later, we invented a way to use a virtual analyzer and get the same data in 2 minutes. Almost real time. So, virtual analyzer, the one we built, gave them an opportunity to create a new product for our client, uralchem, which is called a virtual hint. In the future, we want to automate this helper to make the pulp quality consistent automatically. To develop technology 4.0, which goal is to create digital models and digital twins of some productions. We will use 5G networks that will allow manufacturers and producers to get data live with minimal latency and to transfer large amounts of data. Another moment for this technology is that its design allows to create slices, which means certain technological channels, and provide a certain level of safety. According to GSMA reports, around 90% of managers are considering implementing private wireless 5G networks. There's already a set of scenarios they see that can be implemented, and we are actively working on deploying these networks for a set of clients. We already have a test 5G network in Skolkovo, where we conduct experiments. using startups technology, including Russian manufacturers, and also work on industries like Sepur Kimprom. Thank you for your attention. Any questions?